Welcome back. Section 2.4, chain rule. So this is going to be our last rule that we're going to talk about in generalities, I guess, with our different rules for derivatives. So remember we had the power rule, when we had something just to an exponent, a variable to an exponent. We had the product rule, when we had two things being multiplied together. We had the quotient rule, when we divided two things together. And now we have the chain rule, where we have the composition of functions. So remember f of g of x, that's the composition. We saw fog, if you remember, or we wrote it as f of g of x. So whenever we have a function within a function, the first types of problems that we're going to look at when we do this are going to be quantities to an exponent. That's going to be our first kind of chain rule, kind of basics that we talk about, and then we'll get into some trig, some exponentials, and so on and so forth. So 2.4 is going to be kind of a lengthy section here. We've got a lot of different types of the chain rule, different places that the chain rule is going to be applied. So what do we got here for our rule? So h of x is going to be a composite function, f of g of x. H prime of x then is going to be f of x. G of x is going to stay the same, so f prime of g of x times g of x. So we took the derivative of the outside function, the inside function stayed the same, and we took the derivative of the inside function, g prime of x. And what we're going to see there, kind of an alternative form of this, or kind of the way it's going to work today, is going to be when we have a function to an exponent. This kind of looks like the power rule, and it is, where we have a quantity to an exponent, but now this quantity is going to be in terms of x's, and it's going to be more than just a single variable. So if we had maybe just x squared as our function, we took that derivative, f prime of x, as being, we took the 2 to the front, and then we decreased the exponent by 1. What this is telling us to do is to also take the derivative of that function. Well, if I took the derivative of x is 1. So I would end up with a 2x. So we can think of the power rule as being a chain rule, but we don't necessarily need to. So again, if we're given a function as being a function to an exponent, we're going to bring the exponent to the front, multiply it to the front. We're going to leave that function the same, decreasing the exponent by 1, and then take the derivative of the inside. What's that going to look like in number form, in term form here? So if we give you f of x is 2x minus 3 to the fourth. So 2x minus 3 is our quantity to the fourth. The derivative of this, we're going to bring the exponent to the front. We're going to leave the 2x minus 3 alone. We're going to decrease that exponent by 1 to 3, and then we're going to take the derivative of the inside function. Derivative of 2x minus 3 gives us 2. We can clean this up. Our 4 times our 2 gives us 8, 2x minus 3 to the third. And that's going to be our derivative. We can get very ugly and very nasty in a hurry with these, of course, as you can see in example 2. Example 2, we have 3x plus 1 to the third. We're going to multiply that to 2x minus 1 to the second. If we ask you to find the first derivative of this, well, here we have the product of two things, and each of those things is going to be to an exponent. So the first derivative, remember product rule, we have 1, our first, and then derivative of the second. So we have a chain rule here, we have a quantity to an exponent. So we're going to have our 2 coming to the front, inside stays the same, decrease the exponent by 1, and then derivative of the inside, which is going to be 2. 2x minus 1 derivative is 2. So what I like to think of with our basic rule here, we have 4 parts to this chain. We have the exponent, we have the inside staying the same, the new exponent, and then derivative of the inside. So kind of 4 links to that exponent. Doesn't always work with a chain rule that we have 4 links, because when we get to trig, it's a little different. But that's kind of what's going to happen today. You're going to have 4 different parts to this today. So to this, we're going to add the second. So our 2x minus 1 to the second, and then derivative of the first part here. So our exponent comes to the front. Inside stays the same, 3x plus 1, decrease the exponent by 1, and then derivative of the inside again, which is our 3. We can clean this up. Not that we necessarily need to. Extended response, multiple choice. We definitely saw this last year in pre-cal, and in Algebra 2 the year before, where I asked you to clean this up. We can factor out 3x plus 1 squared. We can factor out 2x minus 1 to the first. So what are we left with here? We have 2 times 2, which is 4, and then a 3x plus 1. And to that we're going to add 3 times 3, which is 9, times a 2x minus 1. Go inside here. We got what, a 12x plus 4. And to that we have an 18x minus 9. So our nice clean multiple choice answer would probably be 3x plus 1 squared. 2x minus 1 to the first, which we don't necessarily need the 1 there. And then we have a 30x minus 5, which you could actually pull that 5 out if you really want to. So looking to me like a multiple choice answer would be 5 times 3x plus 1 squared times 2x minus 1 times 6x minus 1. And that's where I would probably like for you to get to on a multiple choice question. We can do this with quite a bit of things. I'll show you here. We have some radicals that we're working with in this example. First thing you got to remember is how to change a radical into an exponential or a fractional exponent. So remember the exponent inside the quantity there, inside the radical, is going to be the numerator. The index here is going to be the denominator. So our original function, we could write it as x squared plus 2 to the 3/4. So our first derivative, we're going to bring that exponent to the front. We're going to leave the inside the same, decreasing the exponent by 1 to negative 1/4, and then the derivative of the quantity or the inside there. Negative exponent's going to go to the bottom. We can clean it up. 4 and the 2 is going to cancel here, so we get 3x divided by 2 times x squared plus 2 to the 1/4. And that'll be our first derivative. In our example here, we have 2 radicals. Again, I'm going to go ahead and change those to fractional exponents. And actually with this one, notice our 2 exponents are the same, so we could actually write this as one big quantity. X plus 3 over 2x plus 1, all to the 1/2 power. If I didn't write off the paper there. So that's the way I would probably tackle this problem, because here we'd have a quotient rule, and within that quotient rule we'd have 2 chain rules, or 2 chain rules. Here we have one big chain rule. So I would probably tackle it in this manner here. I think it's going to make it a little nicer. So the derivative there, we're going to bring the 1/2 to the front. Again, that quantity is going to stay the same, decreasing the exponent by 1. And then derivative of the inside. Derivative of the inside, we have the quotient rule. So 2x plus 1 times 1 minus x plus 3 times 2 divided by 2x plus 1 squared. So cleaning this up for a multiple choice, we have 1/2 negative exponent. It's going to flip that fraction, and we're going to split it up as well. So 2x plus 1 to the 1/2, x plus 3 to the 1/2, and then times, we have 2x plus 1 to the second on the bottom. Multiply this out, we get a negative 2x minus 6. We multiply the 2 through and the negative through. The x's cancel, so we have a negative 5 on the top. And we can clean this up. We have 1 times negative 5, 2x plus 1. Half of those are going to cancel. So on the bottom we have 2, x plus 3 to the 1/2, and then a 2x plus 1, we had squared, or 4/2. And we take out a 1/2, so we're left with a 3/2. And that's going to be our first derivative of that nasty looking function. All right, and last but not least, again, a nice AP kind of question. H of x is g of f of x, so we have to recognize that this is a composite function. If I want to find h prime of 2, I'm going to find first h prime of x. H prime of x is g prime of f of x times f prime of x. So h prime of 2 will be g prime of f of 2 times f prime of 2. So h prime of 2 is going to be g prime of f of 2. F of 2 is -1. F prime of 2 tells us that it's 2. G prime of -1 we see is 3 times 2, or 6. And that would be an example of something that you would see, again, more theoretical. We've seen those with the product and the power rule and the chain rule so far. So be able to see that a function is going to be one of these rules, not just explicitly told to us. Good luck!